6 digits, I have to make maybe 3-digit number. Okay. So what we discussed, by using these 6 digits, you have to make 3-digit number. So first 100 place will have 6 options. You can choose any one of the number out of 6. Next one will have 5 option where repetition is not allowed. Okay. And the next one you have 4 option. So my answer is going to be 6 into 5 into 4, right? 6 into 5 into 4. This I can rewrite it as, let me insert the equation. So we can rewrite this as 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So what extra here you have only 6 into 5 into 4, but here I written 6 to 1. What is extra you are putting? 3 into 2 into 1. This is the extra term you are keeping. So I divide with the same term. Now both will be same. 6 into 5 into 4 is same as 6, 5, 4, 3, 2, 1 upon 3, 2, 1. Both are same, but just we are written in the different way. Yeah, it is 120, but I don't want the answer now. We are going to derive a formula here. So which is equals to, numerator is 6 in, you have the product from 6 to 1. So I can say that as 6 factorial, and the denominator I can say it as 3 factorial. 6 factorial equals to 3 factorial, but still I can rewrite this as this. I keep 6 factorial as it is, 6 factorial upon, and the denominator I'll make it as 3 as 6 minus 3 factorial. This will be same only, right? 6 factorial upon 3 factorial can be written as 6 factorial upon 6 minus 3 factorial. Both will remain same. Now here if I generalize this formula, if I have 6 objects here, out of 6 I am selecting 3 objects. So my formula is coming as 6 factorial upon 6 minus 3 factorial. So if I generalize this formula, like if I have n objects and I am taking r objects, so how the formula is going to be n factorial upon n minus r factorial. Okay. Here n value is 6, r value is 3 in the above example. Similarly here also, if I have n object and out of n if I am taking r objects, so my formula is going to be n factorial upon n minus r factorial. So this can be written as, which will be same as yeah. No, not this. Just a minute. Huh? Yeah. So this can be same as n p r. If you want to explain NPR formula, so we call it as NPR. NPR formula is n factorial upon n minus r factorial. So what is the explanation for this one is, out of n objects, I have to arrange r objects only. Sometimes r may be same as n, sometimes r may be 0, r may be 1, r may be 2, but r value will be less than or equals to n. It can be more than n. Okay, so this is one of the formula where the repetition is not allowed. If I want to arrange r objects out of n objects, so I can call it as npr, and the formula is n factorial upon n minus r factorial. Now for the same example here, there are numbers 1 to 6, and I want to make again 3-digit number where the repetition is allowed. Okay, if repetition is allowed, what we say, first place will have 6 options, second place will have 6 options, third place also will have 6 options. This is 6 cube. Okay, out of 6 object, if I allow the repetition, then you are making 3 digit number, then it will be 6 cube. If you are making 4 digit number, then 6 to the power of 4, then you are making, yeah, and if you are making 5 digit number, it will come as 6 to the power of 5, because 6 into 6 into 6 to 5 times you have to multiply. So in the same way, if I generalize this question, if I want if I want to, out of n objects, if I have r objects, if the repetition is allowed, so my formula is going to be n to the power r. Okay, n will be multiplied r times. So these are the two theorems which we have in our book. First one is n factorial upon, yeah, here it is. NPR is n factorial upon n minus r factorial, where r value will always be less than or equals to n and greater than or equals to 0. So there are certain formulas np0. That means out of n objects, I'm not taking any objects. That is also one permutation. np0 value is 1 because according to the formula, it is n factorial upon n minus 0 factorial. N minus r, here r is 0. So n minus 0 is again n factorial and numerator also n factorial. Both will get cancelled. So answer is 1. So np0 value is 1. Similarly, you can find out what is npn, where r equals to n. If it is npn, then I'll get n factorial upon n minus n factorial. N minus n is 0 factorial. We consider 0 factorial as 1. So npn value is always n factorial. Okay. Because out of n objects, you are taking all the objects. So here, if I want to go by this example, out of 6, there are 6 numbers and you are making 6 digit number. So what you get? 6, 5, 4, 3, 2, 1, which is nothing but 6 factorial only. So like this, out of n objects, I am taking all the objects. It is going to be n factorial. So these are the basic terminology or formulas you can say. So next one we have is third one. Till now we discuss a repetition is allowed, a repetition is not allowed. Then here the next one is permutation when all the objects are not distinct objects. So what do you mean by all the objects are not distinct? So here if I consider 1, 2, 3, 4, 5, 6, you may ask why are taking this example only. We can take any other example, the process will remain same. So here all the numbers digits which you have is different, right? But the same question I can ask you in another way. 1, 2, 3, 1, maybe 3, 6. Here also it is given to you 6 digits. 1, 2, 3, 1, 3, 6. Again, I'll ask you how many 3-digit numbers you can make by using the given number. Now here the digits are repeating. 1 is repeating twice, 3 is repeating twice. So in that case, for example, here I put my 3-digit number is 1, 1, maybe 3. If I keep my 3-digit number as 1, 1, 3. So let me remove this one. Yeah, my 3-digit number I keep. This is one of the 3-digit number, 113. Now by interchanging this 1 and 1, second one in the first place, first one in the second place, still my number will remain 113 only. Okay. So here I opted for 3. I don't know whether I opted this 3 or this one, second one. Still my number is going to remain same. That means when the digits are repeating, appearing more than once, then the permutations, number of permutations will increase or decrease. What do you say? If the digits are allowed to repeat here, the given digits are repeated, then the permutations will increase or decrease. Decrease. Yes, it is decreases. Because why it is decreasing? If I have 1, 2, 3, 4, 5, 6, By interchanging the position of the digits, I get the different number. But when the repetition which we have, whether you take here 113 or if you interchange, still my number will remain 113 only. So some of the permutations will be repeated. So total number of permutation will also automatically decreases. So that is the concept permutation when all the objects are not distinct objects. Okay, so we have the formula for this. So here they are given. I think this explanation we consider. So here the number of permutations of n objects where p objects are of the same kind, then the formula is n factorial upon p factorial. If the more number of digits are repeating, that is p1 objects are of same one type, p2 objects are of another type, and so until pk objects are of kth type, then the formula is going to be n factorial upon p1 factorial, p2 factorial, and so on, pk factorial. I'm sure you are not getting this one. We'll take an example, then you will understand easily. I think in the last class I explained this one. Okay. I'm going for when all the letters are not distinct. I think everyone has heard about this word, Mississippi. Whatever you say. So in the second example, what happens here is, if I want to make again four-digit four-letter word by realizing how many four-letter words we can make using the letters from the word book. That is the question. Some 4 factorial has to come, but the repetition is there. So it is going to be 4 factorial upon O is repeating twice. So it is 2 factorial. That is what they said in the first question, first formula. Where is this one? Not here, not here. Yeah, this one. The number of permutations of n objects where p objects are of the same kind, then the formula is n factorial upon p factorial. That means only one object is repeating p times. Then my formula is n factorial upon p factorial, where I have here book. The word which I have is book. Then only O is repeating twice. None of the other letters are repeating. So it is 4 factorial upon O is repeating twice. So it is 2 factorial. If, for example, if I have book, so it will go as 6 letters are there. So 6 factorial upon, still it will remain 2 factorial only because only O is repeating twice. Okay. So, but if I comes to the word Mississippi, how many letters are there in Mississippi? 4 plus 4, 8 plus 3, 11. So here I have 11 letters in the word Mississippi. So I can put it as 11 factorial. Can anyone tell me what comes in the denominator? As many letters are repeating, that many factorials will come in the denominator. For example, let me see if somebody has given the answer. 10 are there, they are 11, I think. Uh, in Mississippi, 10 are there. 4 plus 4, 8 plus 3, 11. Now, in the denominator, for example, S is there. The word S, 4 times it is repeating. So it is 4 factorial multiply by, what else is repeating? I is repeating 4 times. So again 4 factorial will come. And what else is P is repeating? So multiply by 2 factorial. Anything else is repeating? No. Acha, you are saying 10 factorial because 4 plus 2 is 10, 10 factorial. No, 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 not that way. S is repeating 4 times, so 4 factorial. I is repeating 4 times, so it is again 4 factorial. P is repeating twice, that is again 2 factorial. If any other letters is repeating so many times, again into that factorial will come. but here we don't have anything. So this is the formula for that one. So that's what your second theorem says. Okay, maybe those who are given 10 factorial by adding them. So this is the what theorem says. Theorem number 4. The number of permutations of n objects where p1 objects are of the one kind, that is like S is repeating 4 times, that is one kind. P2 are of the second kind. So P2 means, for example, I is repeating 4 times, and like this, if till pk terms are repeating, k can be 1, 2, 3, 4, 5, 6. Okay, as many. It should be less than n again. So then p1 factorial into p2 factorial into p3 factorial till pk factorial. So they have to be multiplied, not added and put the. Who is this? Priyanshu Mishra. Now you are joining the class at the end of the class. Okay. So this is when repetition is, words are repeating, letters are repeating. So this is the way to solve. Is this clear? These theorems, we discussed 4 theorems. One is NPR formula, without repetition, with repetition. Then the letters of the words are appearing more than once. All these things are clear. I want reply from everyone. Sahil Raipurkar, clear? No reply from Sahil. You are not at all studying, huh? Okay. So we'll move to the next one. So here they are given the word Allahabad. Find the number of permutations of the letters of the word Allahabad. So in Allahabad, there are total 9 letters are there. 9 factorial upon A is repeating, I think, 4 times. So 4 factorial. L is repeating twice. 2 factorial. I think after that, none of the words are repeating. So let's stop here. Next one. How many 4-digit numbers can be formed by using the digits from 1 to 9 if the repetition of the digits is not allowed? Okay. So by using the letters, anyone can give the answers. You have to use the letters from 1 to 9, and you have to make 4-digit numbers without repetition. You give the product if you don't want to multiply. 1 to 9, 9 numbers are there, and you have to make 4-digit number. So formula is 9p4, yeah, 9 factorial upon 5 factorial, or 9 into 8 into 7 into 6, that is also okay. NPR, right? Here N is 9, R is 4. So 9p4, therefore 9 factorial upon 9 minus 4 factorial, that is 9 factorial upon 5 factorial. Yeah, it is correct. Next one is, how many numbers lying between 100 and 1000 can be formed with the digits 0, 1, 2, 3, 4, 5 if the repetition of the digits is not allowed? That means you have to make 3-digit numbers excluding excluding 100. So how many digit numbers you can make by using 0, 1, 2, 3, 4, 5 where repetition is not allowed? Anyone? Gagan said 100 is given. You can take 1 minute time and solve it. How 100? Any explanation? I think this type of questions we discussed once, where especially when 0 is there. You have to make 3-digit number, right? So when I say 3-digit number, mostly generally what we are habituated is there are 6 numbers. So first place will have 6 numbers. Then second place will have 5 numbers. Third place will have 4 numbers. 6 5s are 30, 34s are 120. No, it is wrong. First place won't have 6 options. because 0 cannot be in the 100 place. If 0 is in the 100 place, then it will be a two-digit number. So first place will have only 5 options: 1, 2, 3, 4, 5. Then second place will have another mistake they do is they put 4 here, they put 3 here. Again, it is wrong. See, from 1, 2, 3, 4, 5, there are 5 options for the 100 place. We can keep any one of the number. 4 more numbers will be left. For example, if I keep 1 here, then 2, 3, 4, 5, and 0 also will be left out. 0 can be in the second place, 10th place, no problem. Second place also will have 5 options. Out of these 5, from 1, 2, 3, 4, 5, one of the number will be kept in the 100 place. 4 more numbers will be left out of 4 plus and this 1, 0. So again 5 options will be there in the 10th place, and hence for the unit place you will have 4 options now. So 5 5 is a 25, 25 4 is a 100. Yes, 5 into 5 into 4. That is correct. So like this we can make 100 outputs. So they are done some another way. You can just go through this way. You can use that method also. Yeah, now this type of questions are important. We have find the value of n such that np5 equals to 42 into np3. So what I do here is np5 formula I will write. Np5 formula what we have, this is example 12. So let me write. So it is LHS is given as np5. So according to the formula we have n factorial upon, so capital letter is there, n factorial upon n minus 5 factorial, n factorial upon n minus 5 factorial will come is equals to 45 into, so what we have another one, np3. Achha, this is 42. 42 into np3. This is 42. np3 formula is n factorial upon n minus 3 factorial. N factorial upon n minus 3 factorial. Okay. The given question I will change. I will use the formulas as written in the simplest form. Now, if you observe carefully, both numerators n factorials are there, so both n factorials will get cancelled. Okay, both n factorial will get cancelled, and I do the cross multiplication, and I'll show you what you get. N minus 3 factorial is equals to 42 into n minus 5 factorial. N minus 5 factorial. Now, out of these two factorials, one of the factorial I have to expand. So if I expand n minus 5 factorial or n minus 3 factorial, if you observe the factorial formula carefully, let me put somewhere here. N factorial formula we discussed as n multiply with n minus 1 multiply with n minus 2, then multiply with n minus 3 multiply with, and so on. It will go till 2 multiply with 1. Once I reach 1, then I stop. What happens here it is the numbers keep on decreases. N is bigger, n minus 1 is smaller, n minus 2 is again smaller than the previous numbers, then n minus 3 which is smaller than the previous numbers, right? So here what I have to expand is n minus 3 factorial. I can write it as n minus 3 into n minus 4 into n minus 5 factorial. If I want, I can expand n minus 5, then n minus 6, then n minus 7 till you reach 1. But I stop at n minus 5 factorial equals to 42 into n minus 5 factorial. Are you getting this expansion? You cannot, generally student make the mistake here. They expand n minus 5 factorial as n minus 5 into n minus 4 into n minus 3 factorial. That is wrong. The bigger number has to be expanded till you reach the smaller number. Here I think n minus 3 is bigger than n minus 5, because from n you are subtracting 3 here, and here it is from n you are subtracting 5. So n minus 3 is bigger. So bigger number will be simplified till you reach the smaller number. So n minus 3, n minus 4, n minus 5. Now what happens is this n minus 5 factorial will get cancelled on both the sides. Then what you left out is n minus 3 into n minus 4 is equals to 42. So n minus 3 into n minus 4 equals to 42. One method is you open it and simplify. Here's the quadratic equation. Or another way is we can write this 42 as 7 into 6. Okay, because n minus 3, n minus 4 are two consecutive numbers. So 42 I have written as product of two consecutive numbers. So here you can take now n minus 3 equals to 7. Then you will get n value as, I think, 10. So second option you can take is n minus 4 equals to 6. This also will give you n value as 10. You can choose any one. Okay. So just hold on. So this is how we'll solve the question. So we got the n value as 10. Is this clear? What about others? Okay, good. So if you take the next examples, so like this, you can simplify the further examples also. See, here I solved by factorization like 7 into 6, or else you can expand this one as a quadratic equation, n minus 3 into n minus 4. Then you get the quadratic equation. You can use that method, splitting the middle term or quadratic formula, whichever is easy. Then rest all are same. 5 times of 4pr equals to 6 times of 5pr minus 1. So they expanded the formulas. Okay, so till here you tried. Then this from example 4 onwards we'll discuss later on. Then what else we have here is exercise 7.3. So see what are the questions you can solve. I think till question number 7 you can try it out. Can you?